Yeah, we're going to do number 6, right? We did all the way to number 5? Where we figure out that he cannot dunk. Yay? Mm-hmm. All right, so are we good? All right, a diver is standing on a platform 24 feet above the pool. Okay, so what's that's 24? Okay, so but what is it in the equation? My what? My y-intercept, because that's your starting point. Very good. That's my y-intercept. He jumps from the platform with an initial upward velocity of 8 feet per second. Use the formula h of t equals negative 16t squared plus vt plus s, where h is the height above the water. And what's the height above the water? What's the height above the water? No. Where is he? Where is he located? So what is the height above the water? 24 feet. There you go. Um, T is the time, V is the starting upward velocity, and S is the starting height, right? Which would be, that would be my starting height, right? Okay, how long? How long? So that will be time, so that will be X. Very good. I'm looking for X. Will it take for him to hit the water? Okay, so let's do. This is the water. He's on a platform. And he's here, and he's diving. Yay? So my X is time, and my Y would be, oh look, I put an X, that's Y, would be height. Yay? Alright, X is time. It's hot in here. Alright, so let's come up with the function first. H of t equals negative 16t squared plus what? Plus what? 8t. And then plus what? Thank you, Rolando. Plus 24. So we got to figure out how long will it take for him to hit the water, right? So what are you looking for? My what? No, no, no. Tell it. Okay, thank you. You don't tell me you're looking for your x, because there's 100 billion x's. I'm looking for my x-intercepts, which are also called my what? My zeros, which are also called my what? Roots. Okay, so that's what I'm looking for. Because I want to figure out how long did it take him to jump and get into the water. Okay? So what am I need to go ahead and solve this equation, right? Yay? Alright. That seems like it could factor, but I'm not sure. Negative 4, negative 8 could be GCF, right? Remember, you don't want that t squared to be negative. Negative times a negative, right? So that you can have 8t. And then negative times a negative 3. Let me see. And to check, I just go ahead and check it real quick, right? And let's just do my mental math. Negative 8 times 2, negative 16. Negative 8 times negative 1, positive 8. And negative 8 times negative 3, positive 24. So I'm good to go, right? Always try to do that. It doesn't take you but 2 seconds. You do it in your head, and you make sure that you have factored correctly. All right, so now I need to... So 2 is just 2 times 1, and 3 is 3 times 1, and I gotta have a minus 1. Right, so can I just do 2 times 1 and 3 times 1? And then subtract? Yes? Which one needs to be negative? The 2 times 1? The 3 needs to be negative, not the 2, the 3, right? So that when you subtract, you can get a negative 1, right? So the 2 and the 3 are not multiplied together, so they need to be in the same parentheses, right? So minus 3 and plus 1. Okay? Alright, so t equals what? No. 3 halves, which is 1.5, right? And And t equals -1. Which one are you using? The 1/2. The 3/2 or 1.5. Very good. All right. So how long will it take? About a... No, not a minute and a half. These are not minutes. About 1.5 seconds. Unless he's like really, 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 I'm going to say it again, really tall, it's not going to take him a minute. Okay? Are we good with that? Alrighty, let's go to number 7. That's my key. What am I doing? Is this right here, right? Alright, a ball is thrown upward from a height of 15 feet. So I'm going to put somebody on somewhere because there's no way that somebody's 15 feet tall, right? And the ball is thrown upwards, and then it definitely needs to come down, right? Alright, what's your x? Time, and what's your a, your y? Height, right? Alright, so what is that height? What is the 15? What is that? 15, a ball is thrown over from a height of 15 feet. What would that be? Your what? Your y-intercept. So that would be your s, right? And then it has an initial upward velocity of 5 feet. So that would be your v, velocity. V for velocity, right? So my function would be h of t equals -16t squared plus 5t plus 15. Yes? And then you got to figure out how long. That would be what? That will be x. Thank you. That will be x because it's times. Will it take for the ball to hit the ground? So what are you looking for? Your zeros. Your x-intercepts. Also called zeros. Also called roots. There you go. Beautiful. All right. So I need to solve this, right? I don't think there's a GCF for that, and I'm not even going to try to attempt to factor that. So guess what I'm going to use? Thank you. Thank you. The quadratic formula. Very good. All right. So minus b. Plus minus. B squared minus 4 times AC divided by 2a. Okay. What's my quadratic term? What's my linear term? And what's my y-intercept? Alright, so let's go ahead and plug in. You with me? Alright, so -5 plus minus 5 squared minus 4 times -16 times 15 divided by 2 times -16. And then calculator takes over, right? Yay? Shh. Come on, working, working, working. What do we got? Do we have anything? Alright. I'm going to go ahead and go to the equation. We should have done this before we... To figure out if I'm looking for my zeros, my x-intercept, which one is 0? Y equals 0. But look, it goes from 4 to negative 39, which means my seconds will be from 1, between 1 and 2. Okay, 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 we don't know what I'm talking about. Let's go ahead and say it again. I'm looking for when y equals 0. Yes? Alright, so it goes from 4 to negative 39, which means whatever I get from the quadratic formula, it has to be a number between 1 and 2, because it goes from 4 to negative 39, and there's your 0, right? So it's obviously a decimal. Yay? So if some of you panic when you get decimals, don't panic. Just go to the table and try to see if you can find it. Because from the table, I get a second. Yes, it is going to be a decimal. Right? Do we understand what I'm trying to do? Yes? All right. So what did we get from this? So let's see. Let's do it. All right. So negative 0.82? Yes? So obviously it's not going to be that one, right? All right, so let me go ahead and change that plus to a minus. And didn't we say that it was going to be between 1 and 2? There you go. So you can get a verification from the table. All right? So don't panic when you see your decimal. Just go to the table. So it would be 1.14 seconds. Yay? All righty. All right, that was number 7. Let's go to number 8. All right, one of the games at a carnival involves trying to ring a bell with a ball by hitting a lever that propels the ball into the air. The height of the ball is modeled by this equation. If the bell is 25 feet above the ground, will it be hit by the ball? It's kind of like with the rock climbing, right? So you got to figure out if this guy, if when you hit the ball and it makes that parabola, right? Are you going to hit the bell that is 25 feet above the ground? All right? So you're trying to, I don't know how to draw a bell. Oh my God. Okay, there's a bell. Right? And you are hitting something that's going to go up, 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 and you want it to hit the bell and then come down. Yay? This is the bell. Use your imagination. Thank you, my babies. Yay? All right. So I got to figure out if that ball with that function that's going to make that parabola is going to hit that bell that's 25 feet above the ground. So what am I looking for? What do I need to calculate to figure out if it's going to reach that bell that's 25 feet above the ground? The what? Say that again. Thank you so much, Orlando. I don't know what I would do if it wasn't for you sometimes. The axis of symmetry. Thank you very much. We got to calculate the axis of symmetry. Very good. The axis of symmetry. Why do we have to calculate the axis of symmetry? Why? Because what? Okay, that's the purpose, to figure out if it's going to reach 25, but what is the reason why I need to calculate the maximum and add the zeros? Too many people talking to me at the same time, and Miss Marine's old ears cannot handle it. So raise your hand. I'm trying to figure out what? Priscilla? I'm trying to figure out if it's going to reach 25 feet. don't answer the question by restating my question. All right? Because that's not answering the question. How do you know that I need to calculate for the axis of symmetry and not the zeros? Because the zeros is what? Because the zeros are not the maximum? What is the maximum? No, we don't know what the maximum is. That's what I want to know. I want to know if it's going to hit 25. So again, I'm going to ask again. You're just not saying it. You need to be able to verbalize it. That's the only way. For those of you that don't talk, I never know if you know math or not because you don't talk. So I don't know. For those of you that talk, it's really easy for me to say, oop, on point. We got it going on. But for those of you that don't talk, I don't have a clue if you know it or not because you're not talking to me. So maybe I need to start calling out names. Because there's some people in here that don't open their mouth for anything. Alright, so yes, we have to calculate the axis of symmetry. But I want to know is, how do you know that it is the axis of symmetry and not, let's say, the zeros of the function? How do you know that it is the axis of symmetry? What does the axis of symmetry tell you? If it's equal, the what? The minimum? I don't think this one has a minimum.
Because we're not trying to find our x-intercept, we're trying to see how high it can go.
The axis of symmetry tells you how high can that ball get. And you want to figure out if it can reach the bell, which is 25 feet above the ground. What does these zeros tell you? Stop tuning me out. What do the zeros tell you?
When the ball hits the ground.
So it tells you the time at which what? The y equals 0. Which means the height is what? 0. Which would be, if you're throwing it from the ground, before you threw it and when it hit the ground. Yes? Okay, if you don't know those differences, quadratics is going to be quadratics. Applications of quadratics, which are word problems, are going to be very, very painful. You got to be able to think. You have to. And that is something that last year's kids could do. They may not have been wonderful in computations, but oh boy, could they think. So we need to be able to think and tell me why is it the axis of symmetry and not the zeros, okay? The zeros is at ground level. Or at your starting point, right? Because that is not ground, but that's still your starting point. Yay? Alright. So I'm going to go ahead and calculate the axis of symmetry for this because the axis of symmetry tells me the maximum height. Yay? And I need to figure out if it's going to reach that bill that's 25 feet above the ground. So how do you calculate your axis of symmetry? X equals negative b divided by 2a. Yay? Alright, what's my b? Very good. But it has a negative in front of it, so I'm going to go ahead and write it down. And 2 times a, what's a? Negative 16. Alright, so this would be negative 32 negative 39, I'm sorry, divided by negative 32. Yay? Alright, so what do we get? That's a 39. What do we get? Can we please tell me what we get? Can we please tell me what we get? We don't get negative 39 over negative 32. Which equals what? seconds? All right. Is that your answer? If you don't know, read the question again, because I'm tired of doing work for you. Let's go. Evelyn, I cannot hear you.
That's not your answer because they asking if it when he do touch the bell or not.
If it's going to touch the bell. That's not even in feet. That's seconds. So what do I have to do now?
You have to plug it in.
Very good. I have to plug that X in where my T is. Very good. So I'm going to go over here and write down the height, which is what I want. Negative 16. I would write it as a fraction, guys. 3932 squared plus 39 times 39 over 32, and then you can get the height. All right, so what do we got?
I got 1,521/64.
All right, but that doesn't tell me anything because I need 25 feet. So you got to give me a better number to work with, correct?
Yes. 23 plus 74. It right here is 23.7656.
So 23.70 something. I don't see everybody shaking their hands, so I'm either assuming that you don't know how to do it or you haven't done it yet. Which I can give you more time so you can finish it. So what do we got?
23.7656.
Okay, give it to me in hundreds, because I'm not writing all those numbers down. Come on, guys, we gotta use common sense. 23 point what?
77.
77.
Diagonal backwards.
All right. So is it gonna reach the bell or no?
No.
No, it's not. No, it will not reach the bell. Correct? It will not reach. You need at least 25. This is what fairs do. They make you think that you can when you really cannot. So that's why I don't play any of those games. Because it's just wasting your money. Alright. Alright, let's go to 10. We're back to, we'll go back to 9, but right now I want to go to 10. Alright, an amateur rockery club is holding a competition. There is a cloud cover at 100 feet. If a rocket is launched with a velocity of 300, that's velocity. Use the function to determine how long the rocket is out of sight. Alright, so you're lounging up. I can't say that word. And at some point at 1,000 feet, there's some clouds. And you lost your rocket. You can't see it, right? Can you picture what's going on in your head? Yay? Yes? So you got to figure out how long is the rocket out of sight. So the rocket is going to go up, 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 up. And once it hit 1,000 feet, you're going to stop seeing it because the clouds are going to cover it. Then it's going to hit 1,000 feet again, right?
Yes.
When it comes down. Yes?
Yes.
All right. So right here. So from here to here, you're not going to be able to see it. Yay?
Yes.
Can you picture it?
Yes.
All right. So the first thing that we got to do is we got to come up with the equation. H of t. All right. V is for velocity. What is the velocity of the rocket?
332.
And what is the starting location of the rocket? What is the y-intercept?
1,000.
So the rocket starts right here? That's what you're telling me. It's 0. Thank you. Because it's at ground, right? Doesn't tell you that it's at ground, so we're going to assume that it's at ground. If it doesn't tell you it's 15 feet above the ground or it's at a building that is 1250 feet, now you assume that it's at ground. So do I need to do anything else to this equation? No. Yay? All right. So I'm not looking for zeros, am I? So I don't have to solve anything. Am I looking for the maximum height? Am I looking for this? No. What am I looking for? How many seconds did I not see the rocket? What is this, X or Y? Y. So what I'm looking for is, what are my X's when Y equals 100, not 100, 1,000 feet, right? And why do I say X's? Because there's two. There's one right here when it's going up, and there's another one right there when it's coming down, right? Does that make sense? And then I got to figure out how much was it from here to here. So what's the best strategy to solve this? Thank you. Oh my God, girlie, you're on fire. Commend it without a doubt, Evelyn. You can think, baby girl. Thank you. All right, so let's see. Y equals negative 16x squared plus 315x. And I don't need to graph it, I just need to go to the table, right? And I'm looking for when my y's are equal to 1,000. Oh, so look at this. It goes from 801 to 1,000. So it's between 3 and 4. So my first one is between 3 and 4, right? All right, so let's go to the other one. Is there another one? There it is. Between what? 15 and 16? Yes? Do you see it? How it goes from 1125 to 944. Why did Miss Marine not go to the negative numbers? Yeah. It starts in 0, right? So there you go. All right. So it's between 15 and... So tell me, about how many seconds was I not able to see that rocket? About how many seconds? 1 second? This one was between 3 and 4, and that one was between 15 and 16. So Gabriel, you care to enlighten the group? Between about 12. About 12. What is the difference between 3 and 15? 12. What is the difference between 4 and 16? 12. So he's telling me between 12 and 10 because he knows that it's between that interval. Very good. So it's about 12 seconds. Again, that's why you got that 100 on that last quiz. I'm telling you, you have to be able to think to pass this test, guys. You have to. Okay? Have to be able to think. At least my test, you have to be able to think. On the STAR test, it's not going to be as hard as my test, but you got to be able to pass my class, correct? With a 70 or higher. All right. Are we good?